Okay, so last time we were able to continue with the discussion in the SN1 reaction, and there are several factors that would favor an SN1 and an SN2 reactions. For example, if we are talking of the substrate, if the substrate of the substitution reaction has a 3-degree alkyl halide, the reaction will favor the SN1 mechanism, while if the substrate has methyl 1 degree or 2 degree, it will favor rather the SN2 reaction. Again, the reason for this can be attributed to the reaction mechanism. In the SN2 reaction, it is a concerted reaction. There is a simultaneous nucleophilic backside attack. So therefore, the presence of alkyl halides on the partially positive carbon will hinder, and that's why for an SN2 reaction it favors methyl or 1 degree substrate. For the SN1, it will favor the 3-degree substrate, because in the 3-degree alkyl halides, it will form a 3-degree carbocation, which is more stable than the 2-degree or the 1 degree. Now, for the nucleophile, we've learned that the SN2 is the only reaction that will be dependent on the substrate and the nucleophile. So therefore, for the SN2, a strong Lewis base and an increase in concentration, of course, also will increase the SN2 reaction, and of course, it will favor the SN2 reaction. For an SN1 reaction, it will favor a weak Lewis base, neutral molecule, or even a solvent. That usually, if we use a solvent, we have the process called solvolysis. For SN2, again, you will have a strong Lewis base, usually with a charged Lewis base. For the solvent naman, SN1 favors polar protic solvents, and the reason is that it will form a hydrogen bond with the it will form a hydrogen bond with the leaving group. It will assist in the leaving group to live on the substrate, and therefore stabilize the leaving group. Because the first step in the mechanism reaction, the SN1, is the formation of the carbocation. So any proton from the solvent, polar protic solvents, will assist in the dispersion of the developing negative charge, partial negative charge on the leaving group. That is for the polar protic solvent in the SN1 reaction. For the SN2 reaction naman, it favors polar protic. Katong mga solvent nga walay proton, like DMF, DMS, so you can again look at their structure. And in the presence of this polar protic solvent, it will form, it will solvate more on the cation of the nucleophile. And then the nucleophile will always have cation, especially for a strong nucleophile. Na siya counter ion, positive counter ion. And so the positive counter ion will be solvated by the solvent here, and your nucleophile will be more reactive to attack on the substrate. For the leaving group naman, for the SN1, it favors, of course, the larger leaving group, the larger size of the leaving group, both for an SN1 and the SN2 reaction. The weaker the base after the group departs, the better the leaving group. Again, the reason for the larger the size of the leaving group ion when it leaves the substrate is because of the polarization. The larger the size of the ion, it will be more stabilized due to the polarization. Okay. So let's look at the functional group transformations using the SN2 reactions. So the SN2 reactions are highly useful in organic synthesis because they enable us to convert one functional group into the other, a process that is called a functional group transformation or a functional group interconversion. So we can form a different kind of functional groups just simply by using the simple substitution reaction, particularly the SN2 reaction. So when the SN2 reaction, just like here, no, in the SN2 reactions, methyl primary or secondary alkyl halides can be transformed into different functional groups. For example, you have an alkyl halide, RRX, no? Your X can be chloride, bromide, iodide, and your R can be 1 degree or 2 degree. Of course, we know that for an SN2 reaction, it favors methyl 1 degree, 2 degree, not the 3 degree. No? So your R should be this, and then your X will be your halides, no, in the group 7. Now, if we do SN2 reaction, depending for our nucleophile, like for example, you have your hydroxide, if it's negatively charged, no, it's a strong nucleophile, as we've learned that the SN2 reaction favors a strong nucleophile, and the more negatively charged a nucleophile is, the more nucleophilic it is. Okay, so of course, na siya counter ion. No, when we add our nucleophile into our mixture, pag magpa-reacta, there's always that counter ion. So for example, sodium hydroxide, no, or sodium alkoxide, something like that. Pag negatively charged, ana siya counter ion. And of course, we've learned that in the presence of a protic solvent, that counter ionic, for example, sodium is solvated by the solvent, and only this nucleophile here is very exposed to readily attack the substrate here. So if your nucleophile is hydroxide, so we can form actually an alcohol. So the X will be substituted with OH, and we can form a functional group alcohol. If the nucleophile is OR, then we can OR or alkoxy, so sodium, for example, alkoxide. Okay, so we can form OR, we can form ether. If it is a thio, like let's say sodium, not sulfide, hydrosulfide. Okay, you can form actually a thiol here. And then RS, you can form a thioether, just like your ether here, but instead of oxygen, you have your sulfur. And then you can have your nitrile, sodium nitride rather, not sodium nitride, sodium nitrile. Okay, you can form actually your nitrile here. And then your carbide, no, sodium, depending sa number of carbon, you can have your carbide. Okay, so you can form an alkyne rather. And then your carboxylate, like say for example, sodium carboxylate, or depending sa number of carbon, like say 2 carbons, so you have ethanoate, sodium ethanoate. Okay, you can form an ester for that. If our nucleophile is amine, you can form a quaternary ammonium halide. And of course, when nitrogen forms 4 bonds, it becomes positive. And of course, you expect that whenever sodium, rather nitrogen becomes positive, no, there's always a counter ion near the positively charged sodium because it becomes ionic now. So there is the one from the halide, no, leaving group will be in closer contact with the carbocation here to disperse the charge, or to make your product on a neutral state, of course. So you have a quaternary ammonium halide, and then you can also have your nitride as your nucleophile, and you will have your alkyl azide. Now, on the strength of the nucleophile, just have to remember on which one will be more nucleophilic or which one will be more basic, no? As shown in the previous slide, just have for the same group, it's easy to remember. The same row, it's easy to remember, but when we are using a different atom, nucleophilic atom, so just have to kind of discern, no, which one will be more nucleophilic. So the trend was already indicated in the previous slide. Alkyl chlorides and bromides are also easily converted to alkyl iodide by nucleophilic substitution. So not just just to other functional groups or other class of organic compounds. You can also change the halides by reacting with another halide non-nucleophiles. For example, RCl, alkyl chloride or alkyl bromide, you can have, and your nucleophile will be iodide so that you can have your alkyl iodide, the larger one. So another aspect of the SN2 reaction is of great importance is the stereochemistry. Okay, so remember that when there is this SN2 reaction, there is an alteration in the stereochemistry from the initial reactant, since it is always a backside attack. With respect to that of the leaving group, there will be an inversion of configuration when we have our product. So SN2, as I mentioned, will always have an inversion of configuration at the atom that bears the leaving group. So what happens to the SN1? Since we form a carbocation first, you will actually have two types of configuration that will be produced. So there is retention of configuration and there is a new configuration, 50-50%. And for the SN1, there will always be resinization. Pag equal siya, 50-50% of the products, with two different configuration, then you will have a racemic mixture. For the SN2 reaction, again, it's a backside attack and it's concerted to the nucleophile. So if the initial product, initial reactant would have a configuration of R, then the product will have an inversion of R, which becomes an S. Of course, you will have a different product because you have a different group being attached to your positive carbon or partially positive carbon. Okay, so starting with S2 bromethane outline the synthesis of the following compounds. This becomes your assignment. So there are too many assignments. So I expect maybe next meeting we'll have our short quiz. Not sure if it's multiple choice or true or false. So definitely we'll have a quiz so you practice on the problem sets, and then we'll have our quiz. So starting with S2 bromobutane, outline the synthesis of each of the following compounds. So of course, when you are given with a name only, you have to write on the structure. What is the structure of 2-bromobutane? So butane, you'll have 1, 2, 3, 4. Of course, 4 carbon atoms, and 2-bromo, you have 1, 2. Of course, you have your bromine. And then, since you have your product here, the OCH2R, what do you expect from your reactant? So if you have 1, 2, 3, 4, you have this 4, and your reactant will be on the second carbon. Of course, you have your bromine, and then your reactant will be this. You can have your CH2CH2O, okay, and make it like negatively charged. So that becomes your, that becomes your nucleophile. It's so easy. Okay, so you have OCH2, CH3, negatively charged. Of course, when there is a negatively charged nucleophile, there's always a counter ion. What do you mean by counter ion? An ion that will balance the negatively charged ion here. There's always this sodium. So usually sodium, potassium. If it's cationic, which is monoionic, cations, which is positively charged. So when you have this, it can attack your carbon. You have your 1, 2, 3, 4, okay, and your bromine. And did it say this is an R, okay, this is an R. Your product is an R, so you expect your reactant to be an S. So how do you make an S? Now remember your stereochemistry, you have to write in a way that you write the S form. So let's look kung S ba ni siya. So the one that's drawn kaning sa line, kaning normal line, it means that it is on the plane, right? Pag broken, it means it is oriented away from you. And pag wedge, it means it is oriented towards you. Okay, since the hydrogen is oriented towards you, dapat manggod si hydrogen. When we look at the configuration, dapat si hydrogen is oriented away from us. But malangan na ta, so let's just look at it this way. So triangular siya, si hydrogen oriented towards you. Let's do the configuration, the prioritization of this, and then balihon na lang nato later. Okay? So you have bromine, CH3, CH2Cr. So which one will have the highest priority? Bromine or CH3, CH2Cr? Kinsa man?
Bromine.
Okay, bromine. Next is?
CH2, CH3.
Okay, next is?
CH3.
CH3. Okay, so here, paingon siya sa right, no? And that should have been R. But because baliktad man ang atong pagka-count kay si hydrogen na aman sa inyong atubangan, when we do the configuration, dapat magod si hydrogen na sa likod. So si R man siya, kay si R, paingon siya sa right. So baliktad ani is the real configuration of this. So baliktad sa R is the S. So this one is an S. Alternatively, you can also redraw this para mabutang nimo si hydrogen na sa likod, no? Saan nimo pagbutang si hydrogen nga nasa likod? You will have to imagine nga mag-atubang mo aning front na amo sa likod aning plane, no? So kung kani si CH3 si BR, adto mo mag-atubang sa likod aning plane or likod aning laptop, likod sa inyong phone. That's how you will have to imagine. And then mag-atubang mo sa likod niya, nasa inyong left is, kung dito mo sa likod magtanaw, right? Are you with me? Kung naamo sa likod sa plane, magtanaw, likod sa laptop, likod sa phone. Okay? Sa inyong left, so triangular na siya, si CH3, CH2, CH3BR. Kung naamo sa likod magtanaw, sa inyong left, is si BR. Sa right up, is si CH3. O sa ubos, is si CH2. Okay? So, paano siya? BR, ana. So, it will be S. Okay? So, that's why I'm saying, like, medyo, you have to redraw this one when you're that's why I just made a shortcut, no? Kay kung mag-redraw na ta malangan. I don't know nga no gini akong say new. Ano gini akong Okay, so this is what I'm saying earlier. No? So when we redraw, let's say you want to redraw si carbon. Which means our eye naata diri sa likod magtan-aw. Mani atong mata nasa likod. So sa atong likod, kung mag-atubang ta sa, kung magtan-aw tagikan sa likod, sa atong right is mao ni siya, sa atong left is mao ni siya. Okay? So that you will have your here BR and then si CH3 here. Of course, tubangan sa inyo will be si CH2, CH3, and then sa likod na dayon si hydrogen. No? So that's how we orient. So when we count 1, 2, 3. So it's paana siya. Of course, we get PS. So this one would have a configuration of S. Now, what I'm saying earlier is, kung gusto mong shortcut, kay si hydrogen oriented naman towards you, malangan na tak magsulat na pagtaani. That's why, kung si hydrogen is oriented na sa inyo ha, and then naka-triangular na siya o forma, pwede na nato siya diretsoon. Especially kay naka-plane na ni siya. No? This is already on the same plane, kaning CH3 o BR. And what is oriented towards you and away from you is this. So, pwede inani, but you just have to remember nga whatever configuration niya yung makuha, baliktaron pag niya yung the final. Kaya wala niya siya na-orient in a way when we are trying to write the configuration or when we try to indicate the configuration of this structure. Klaro ba? Klaro sa tanan? Klaro ba?
Yes, ma'am.
hydrogen. So if we just want to look at this way, diretso na siya. So I just have to write red. Comes 1, as you have mentioned earlier. 1, 2, 3. Paana siya. But again, this is not the real one. It should have been R. This is not the real one. Kay pabaliktad siya. So the real structure or the real configuration rather is, of course, imo pa na siyang baliktaron, no? 2S. So from R nga inyong makuha, inyo pa na siyang i-process further na mahimo siyang S. Mo ni ang inyong final nga configuration. Anyway, so you have now the S configuration, and so when we try to attack our carbon, backside attack, no? So paano siya? What will happen is mobaliktad, no? So the same rig hapon sa CH3 paingon na dito. Okay, so unsa itsuraan na? Diba si CH3 diri man paana man. So pag backside attack mo, flip man ni siyang kaning siya ga triangle or murag stance umbrella bitaw oriented towards kani nucleophile and si bromine. Mura ni siya umbrella nga pabaliktad kani imo ni ang kuan. So when the nucleophile will attack, it will be turned inverted rather. It will be inverted nga si H3 mapaingon na dito sa dito. Siya mapaingon po na siya dito, but si hydrogen and si CH3 is up and below this plane man, no? So dito lang siya paingon, pero it's still oriented towards you, and si CH2, CH3 will still be oriented away from you. So CH3 lang ang mamara diri nga side. And then you have a new bond, CH3, CH2O. Yun sa itsura. You have a new bond, and si CH3 ma-flip paingon dito. Si CH2, CH3 nga broken line, still oriented away from you, pero ma-flip siya dito, and sa hydrogen, oriented paingon gyapon sa inyo. Okay, so kanira ang ma-flip kaning same line. So when you look at the configuration of this, si hydrogen is oriented towards you, wedge, no, dark. CH2, CH3 is oriented away from you, still the same. So since the hydrogen is oriented towards you, well, not the usual way of determining the configuration of the structure. Kapoy na og redraw, right? So let's just do the shortcut. Let's prioritize this group. Which one will be the first priority? All CH2, CH3, CH3, CH2, CH3. Which one?
O CH2 CH3.
Okay, so this one will become our priority. Next, you can say next. This becomes our priority. You can say next.
CH2 CH3.
CH2, CH3. And the next is CH3. So 1, 2, 3, paana siya? Unsa man na siya? This is an S or R? Paingon sa left. Kung kanya itong tanawon, 1, 2, 3. It's pa 1, 2, 3, pa counterclockwise or clockwise ning direction? Anyone?
Counter.
Counter. So is it S or R? Kung counter.
S.
This an S. Okay, so again, this is not the final configuration. Nga naman, because we have oriented hydrogen paingon sa ato. Tama? The proper way of determining is dapat si hydrogen away from you. Kay S man atong nakuha ani, and in 10 minutes. Kay S man atong nakuha ani, when hydrogen is oriented towards us. So ang the real configuration of this is R. So baliktaron na nimo, i-invert nimo kay wala man nato gi-invert. Okay, so therefore this configuration is R. But if you want to katong the usual way of knowing ako nag-shortcut ng, then we really have to write because hydrogen is not oriented towards you. Now that's, we need to process it. So again, when hydrogen is oriented towards you, we have to view gikan diri ang napita sa likod ni hydrogen, no? This is where our eye should be, and that is how we should view gikan diri. Si hydrogen, kung dito ta sa likod, aning plane, si hydrogen atong mata na sa likod, aning plane, So kung magtanaw tagi ka dito sa itsura, on our left, upper left is you have your CH3, and then on on your upper left akong giingon. On your upper left is CH3. Okay? Kaya dito man ta sa likod. And then sa atong right is the O, CH2, CH3. O, CH2, CH3. And then sa ubos, okay, oriented towards you na. Kay wedge man na siya. Dito man ta sa likod ng tanaw. So that's towards kaning I, kaning siyang broken. So that becomes CH2, CH3. And of course, babaliktad na siya sa likod. Si hydrogen is, kung dito sa likod magtanaw, si hydrogen is oriented na. Broken na siya, hydrogen. Okay, so this one is already oriented away sa viewer. So with this one is, at this view, this structure here is how we view sa likod, right? So when we do the prioritization, so it's follow this. Priority 1 is this. Next priority, of course, is this. The next priority is this. So 1, 2, 3, you have that direction. And sa na siya, is it an R or is it an S? This is the counter or clockwise direction. Paano? Okay, this is the clockwise direction, and because it's clockwise, this is an R configuration. So what we have actually produced from S, nahimo siyang R configuration. From S, nahimo siyang R configuration. Okay? So katutong kuan ka ganina sa mga tapulan, mag-redraw. Then just reverse, no? Reverse, or there should be a post-processing whatever configuration that you obtain once you prioritize, no? This is not the final one. The S not the final one you have to process. And the only downside, if you have this, is we have the tendency to forget, no, to post-process. Okay, the real, the systematic way should have been kaning i-redraw gid nato, no, when the hydrogen is oriented paingon sa inyo, ha. Pag si hydrogen is oriented away from you, wala na tayo problema, no, we just can easily find the configuration. Okay, that's what we learned. But if hydrogen is oriented towards you, then we do post-processing. We have to redraw in such a way that when we view this molecule in a 3D manner, we will have the orientation as the hydrogen is oriented away from our eyes. Okay, so this one is shortcut, but kung maglibog mo sa shortcut, then redraw and try to use your imagination of the unsay itsura niya when you are looking sa likod of this structure. Okay, so let's continue with number 2, letter B. If you have R, so you have all the same reactants here, 2 bromobutane. So you just have to write all your reactants and then you change your nucleophile. Your nucleophile will change depending kung unsa ning nakabutang diri. So you have your CH3C double bond OO. Of course, you expect this one to be a carboxylate. So kopyahon na ninyo CH3CO. And how would it form a bond here? There should be a negatively charged here, CH3COO, or this is an acetate. Okay, so CH3COO, an acetate, of course, parisa na ninyo og counter ion. Okay, -1 man si CH3COO. And counter ion, let's say sodium. So just copy this in an S structure. I have noticed that though there are those students now when asked for the last exam, write the 3D structure, no? This is how, not 3D. Like the one when you are asked to show the configuration S or R, you really have to write in a way where you have a wedge and a broken line. If you don't write a wedge and a broken line, then even if the carbon is chiral, no, we don't have a way of knowing from the structure what is the configuration. So if you want to indicate the configuration, whether it's S and an R, then you really have to write in this way. Dapat in your structure na amoy broken and a wedge. Okay? So nagihapon, because I remember nato yung nag-answer sa exam nga wala, they don't know how to write the S or the R. No, even if kabalos less sa configuration, no. Or for example, when you already write the structure, you have to verify, is the structure that you have drawn really an S configuration? If not, then for example, nasayop mo og butang, no, si H3 dili niyo gibutang or si hydrogen, then pag check ninyo, pag verify ninyo, oy sayop di ay, of course yung waton is baliktaran lang ninyo, and then restart the process of knowing would it be an S or would it be an R. Okay, so you need to practice so that you can shorten the time when you are trying to analyze on the configuration. So let's say you have, this is your nucleophile, and then when it attacks here, parehasan na there will be an inversion of configurations sa H3. Kani sila tulo, more siyang mabaliktad dito, but if it's oriented towards you and this one is away from you, parehas siya, it will be oriented, this group will be oriented away and towards you. And kani siya ma-flip dito. And so you have the structure. And you can also check again if whether it's an S or it is an R. No? So you have your nucleophile here. And hydrogen is oriented towards you. So your first priority is, what will be your first priority? Ayan. For this, what will be your first priority, Diri Ayan?
CH3, C double bond O.
Okay, so number 1, and the next?
CH2, CH3.
Okay, so 1, 2, 3. So this is paingon counter or counter or clockwise?
Counter.
1, 2, 3. So 1, 2, 3. Paano siya? Is it counter or clockwise? 1, 2, 3.
Counter.
Counter. So what is the configuration of this? Is this R? If it's counter, is it R or is it an S?
S.
It is an S. So anong R man? Ang R man siya. But what you get is an S.
Ang hydrogen naka-face man.
So the hydrogen is oriented towards us, so we need to post-process that S. No, baliktaron na to si S, that should have been an R. Now, if dili gihapon siya ma-follow, kay maglisod din, draw the structure katong kaganina para ma-orient mo si hydrogen away from you. Okay? This is just the shortcut way of knowing the configuration. So for the rest, you can C and D, you can enter. By the way, when it ends, just click again the link when the Zoom ends. No? We can start again the Zoom link. So delete siya, next. Okay, I'll stop the share and I'll click again the Zoom, okay? Or, I mean, I stop the, still have how many minutes left? Yeah, I have less than 1 minute, so we'll end this and join again the Zoom link. Ano naman eh?